Measurement of electrode potential. So the electrode potential can be measured when a cell is used. A cell means a cell contains two half cells. So whenever two half cells are present, then it is connected to form a cell. For this cell, we can measure the electrode potential. But for a single electrode, it is very difficult to measure the electrode potential. Therefore, so we have to use another reference electrode to which the cell can be connected. The Any electrode which is having a known potential, exactly known potential, can be called as a reference electrode. So among the different types of reference electrodes, SHE, standard hydrogen electrode, this SHE can be used as the reference electrode, and its electrode potential is assumed and it is fixed to be 0.00 volt. This is the electrode potential of the standard hydrogen electrode. Now let us study the construction and the working of a standard hydrogen electrode. In the short form, it will be called as SHE, standard hydrogen electrode, or it is also called as NHE, normal hydrogen electrode. The standard hydrogen electrode is made up of the arrangement is like this. Let us see the first construction. So a beaker is taken. Inside this, a dilute HCl electrolyte is taken, and inside this electrolyte, this is the HCl, dilute HCl, 1 molar HCl, and the electrode consists of the platinum wire. This is the platinum wire is sealed inside the glass tube. At the one end of the platinum wire, the platinized platinum is attached to this, welded to this. This platinized platinum is also called as the platinum coated with the platinum black. So this wire is platinum wire is enclosed in the glass tube, and the whole thing is placed inside another glass vessel which is having a bell shaped at the bottom, and it has the small holes at the bottom for the escape of the hydrogen gas. Through this, the outer glass tube, we are going to pass the hydrogen gas at 1 bar pressure. Continuously, we are going to pass. And this hydrogen gas comes and absorbs on the platinized platinum. Platinum black is having the highest surface area, and the hydrogen gas is absorbed on the surface. And after some time, the hydrogen gas present on the platinized platinum and H plus ions present inside the solution, both will be having an equilibrium. The equilibrium is established like this. That is, hydrogen gas uh, loses one electron, that is undergoes oxidation to form H plus ion, 2H plus ion, and 2 electrons are liberated here. This is the oxidation reaction. The reverse reaction also is possible, that is the reduction. Reduction of H plus ion. H plus ion takes the 2 electron and hydrogen gases formed here. This is the oxidation reaction, and the reverse reaction is reduction reaction. And this hydrogen electrode is symbolically represented like this: H plus aquated single line, that is the interface, hydrogen gas, comma platinum. So here in this electrode, the platinum is the electrode which is not directly involved in the reaction, but it supports the hydrogen gas to accumulate on the surface. That is, absorption of hydrogen gas takes place on the platinum surface. So therefore, platinum surface acts as a electrode where the reaction, other reactions takes place. Therefore, this platinum electrode is called as the supporting electrode or the inert electrode. This is called as the inert electrode. Now we shall go because of this equilibrium established here, the electrode will be having the potential E is equal to 0.00 volt. Therefore, it is having the standard voltage. It can be considered for measuring the voltage of any other electrode. Since this electrode is having a lot of difficulties, we have to go for the other type of electrodes because a lot of drawbacks are there. Um, the other electrode like calomel electrode or the silver chloride electrode can also be used as the standard electrode. So here in the calomel electrode is it consists of the um, glass tube like this. At the bottom of this glass tube, a porous uh, surface will be present. Porous small holes will be present, and it is plugged with a porous plug. And inside at the bottom, you are going to take the mercury. Above this mercury, another layer of paste of mercury and mercurous chloride Hg2Cl2 and KCl, x molar KCl will be taken. And above this, we are going to take the another solution of a KCl, which is having the x molar and Hg2Cl2 saturated solution. That is a solution containing the x molar KCl and Hg2Cl2 saturated. It is taken, and inside this we are going to insert a platinum wire, and it is closed at the top. I used this use for external connection. This is a simple electrode where the depending upon the concentration of HCl and also the temperature, the electrode will have the various values, various fixed values. So therefore, this column electrode is very easy to carry from one place to another place, and also it will be very easy to use and handy in nature, and its value is fixed. Therefore, generally calomel electrode will be used in almost all the laboratories as a standard electrode. Let us see how to determine the EMF of the cell of the copper electrode by using a SHE, standard hydrogen electrode. So when copper electrode is clubbed with SHE, that is the SHE and copper will be internally connected by the salt bridge, and externally it will be connected by the connecting wires. The copper will be having a tendency to undergo reduction. Therefore, it will be represented as the towards the right hand side of the salt bridge. It is copper 2 plus ions which are present in the solution, 1 molar aquated in contact with the copper solid. It comes towards the right hand side, and towards the left hand side the H plus ions will come. H plus ions which are present in the aquated form, that is 1 molar in the solution, in contact with the hydrogen gas of 1 bar pressure. So here the platinum is the reference electrode, and that is the inert electrode. So here the reaction taking place at the copper cell will be like this. Copper 2 plus takes the 2 electrons from the solution, and from the solution copper 2 plus will be deposited in the form of copper solid. So because this reaction is the oxidation reaction, so the SHE will act as the reducing electrode. Reduction reaction takes place at the SHE. So the EMF of the cell is calculated by using the voltmeter. The EMF of the cell is given by the voltmeter. EMF is equal to E naught copper 2 plus minus E naught SHE. So this can be equal to the E naught copper 2 plus bar copper minus 0.00 volt for SHE. EMF of the cell is going to be the value of 0.34 volt. Now this can be written as E copper 2 plus or copper is equal to 0.34 volt. This is a positive value. That is SHE, the EMF of the copper electrode is 0.34 volt using the SHE. To determine the electrode potential of the zinc electrode by using the SHE. Now if we will find out how to find out the EMF of the zinc electrode by using SHE. So when SHE is used as the zinc is used as the electrode, zinc electrode here it is having a tendency to undergo reduction, oxidation, therefore it can act as a left hand side electrode. Therefore in the cell representation we represent a zinc solid single line, zinc sulfate aquated 1 molar, double line H plus ion aquated 1 molar, single line hydrogen gas 1 bar pressure, comma platinum. So like this we can represent the electrode, this complete cell by clubbing these two electrodes. Here the zinc is having a tendency to undergo oxidation, that is zinc loses two electrons to form zinc 2 plus, and this reaction is oxidation reaction. So because zinc is having a tendency to undergo oxidation, we are going to represent this in the left hand side in the cell representation, and the SHE comes to the right hand side in the cell representation. At the SHE, the reaction taking place is a reduction reaction, and this EMF of this cell can be calculated using the equation E naught cell is equal to E naught SHE minus E naught zinc 2 plus. So EMF of the cell is going to be minus 0.76 volt. Sorry, it is plus 0. Actually, voltmeter shows the positive reading only. E naught cell is going to be of the SHE is going to be 0.00 volt minus E naught zinc 2 plus. Therefore, it can be written as E naught zinc 2 plus is equal to minus 0.76 volt. So this is the cell potential of the single electrode zinc to zinc electrode. Like this, the electrode potential of any electrodes can be calculated. There are different combinations of the electrodes. A lot of electrodes are obtained here. Lot of different electrodes can be made. Different combinations can be made. If you find out the EMF of the cell, E naught cell, it is called as the standard reduction potential. Like this, for the different off cells, you can find out the standard potentials, and you can go on arranging them in the decreasing order of the E naught values. E naught will be arranged in the decreasing order. Then we are going to get a series called as the electrochemical series. Now we shall study about what is electrochemical series. In the electrochemical series, the starting from the highest E naught value, the electrodes will be arranged like this. First one is the fluorine gas, takes 2 electron, and it will be converted into 2F minus aquated. So this will be having the E naught value plus 2.87. Then afterwards, the another electrode which is having the 2.01 volt, that is thiosulfate S2O8 2 minus aquated, takes 2 electron, converts into 2S24 2 minus aquated. For this electrode, the value still decreases. Like this, if you keep on writing the different electrodes in a decreasing order, we are going to come to the at the middle, where SHE It is 2H plus aquated, takes 2 electrons, and it will be converted into hydrogen gas. For this electrode, the potential is going to be 0.00 volt. And if you keep on writing the different electrodes, then finally you are going to get the electrode potentials like this: potassium aquated plus electron, double arrow mark, you are going to get K solid. Now for this, the minus 2.92 volt will come. Then afterwards, finally you are going to get lithium aquated plus 1 electron, gives rise to lithium solid minus 3.05 volt. So the one thing in the electrochemical series is all the reactions written here are the reduction reactions. So in here, in between, many electrode half cells are there. I have not shown here in this representation, but actually there are different electrodes are present in between. So starting from the highest value, decreases slowly, and at the in between we are going to get the hydrogen gas which are having the so offset potential which is zero, and finally it comes to the negative value. In the negative direction, the value increases like this. So for the first electrode which is having the highest value, the reaction which is taking place is reduction reaction. So fluoride undergoes reduction to form the F minus ion. So therefore reduction reaction takes place at the electrode system. But in the lithium, if we come to the bottom of the series, lithium is having a tendency to undergo oxidation reaction. That is, the ions is ready to go into the solution. Oxidation reaction takes place. So any electrode which undergoes itself reduction is a powerful oxidizing agent, and any electrode which undergoes oxidation is a reducing agent. Therefore, at the bottom you are going to get the stronger reducing agents. So the elements which are present at the bottom are stronger reducing agents. As you go to the top, the reducing property decreases gradually, and finally you are going to get the oxidation. The elements will be having a tendency to undergo more oxidation, that is strong oxidizing agent. And if you go to the top of the series above the hydrogen gas, the elements are less reactive in nature compared to the elements which are present below the SHE. These will be more reactive in nature. Why they are more reactive means they are having the tendency to undergo oxidation, and they are readily go into the solutions in the form of ions. But here in the above the series, the elements which are in the ionic form is ready to take the electrons and deposit in the form of the atomic forms. They are tendency to go into the atomic form. Therefore, they are less reactive. Anything which is present in the ionic form are more reactive in nature. And also we can also find out from the series whether the metal can displace hydrogen gas from the acid. When a metal is reacted with the acid, these metals which are below the SHE can liberate the hydrogen gas, but the metals which are present above the SHE, these metals cannot react with the acid and they do not liberate hydrogen gas. No hydrogen gas is liberated. And also from using this electrochemical series, we can find out the different electrode combinations, and their electrode potentials also can be calculated. E cell is equal to E right hand side electrode minus E left hand side electrode. Anything which is an electrode, single electrode which is having the higher potential will be taken as the right hand side electrode. The one which is having the lower voltage EMF will be taken as the left hand electrode. So by using this, we can calculate the EMF of the cell readily before construction of the cell itself. These are the important uses of the electrochemical series.